let's do this. So polar coordinates, of course, are another way to, here we go, people, quiet and listening. Polar coordinates are another way, of course, to share or give like distances, locations on the map. Of course, we are used to our standard boring x, y, x, of course, left, y, up and down. I'm going to show you today how those relate to what we like to call polar coordinates, okay, on the graph grid. So R, of course, stands for the radius, so we're on circles. Now, we all know my drawing skills for circles, get ready for that. And then theta, of course, is an angle. Elliot, there's a note sheet, I think, on that desk right behind you there if you want to grab one. There's some extras there. Mrs. Harvey handed them out for me. So, to form the polar coordinate system, fix a point O called the pole, P-O-L-E. I'm wording on this thing. And construct O an initial ray called the polar axis. Okay. So each point can be assigned polar coordinates. Now here again is, like I said, I wish we had color copy machines, because you can see like my R is in red, the radius. And then this is where I said you might need your unit circles today, because we're going to have theta representing angles. So we might see, you know, 45 degrees, pi over 4, pi over 3. We might be back to some of that. So, of course, R is our distance. This is a pain to write on, but we're going to do what we got to do. The distance from O to P. So that is your radius, just for the record. So today you're going to have to use a little Pythagorean theorem. That's not that big of a deal. We're going to have to use our unit circle to maybe do like tan, sine, cos, all that sort of good stuff. Now, this, of course, I just could fit it all in one slide, so this is where the rest of that is. Theta is the angle between the polar axis and the segment. We saw that on the picture. Theta is positive. Remember, your angles are positive if you are measured in the counterclockwise. We know that. That's nothing new. Writing on this thing is going to make me because I don't know why the stuff keeps moving. I know, I get so mad. I'm like, you're right. And then last hour, it's like alternating colors. I pick green, and then all of a sudden a red letter pop in. Then I go back to green. I'm just like, I'm going to have a stroke here. But anyway, okay. Counterclockwise direction from the polar axis. If you have a negative angle, you go clockwise. Maybe if I write slower. Nope, nope. I thought if I went slower. Okay. So clockwise, remember, is down, counterclockwise up. So your standard boring, labeling, drawing angles, nothing has changed. So here we go. Maybe. Plot the points in the polar coordinate system. So remember, do not look at these as x comma y. You're looking at it as radius, so 3 units, okay, and then of course our angle, I'm trying to draw a theta. So first off, I'm going to switch to black here. I'm just going to draw my x and y, my axes here. Now, because of course our radius is 3, so that means I need 3, which is going to be great me drawing this on here, 3 circles. 3 concentric circles, there's a geo term for you, all centered at the origin. And I'm going to try, but it's impossible to do it by hand. I'm going to try to draw them. I'm trying to draw a circle. So that would be radius 1, radius 2, radius 3. Pretend those are all picture perfect, beautifully drawn circles. Bless you. Now, so radius 3, we're clearly going to that last outside biggest circle, and we're going to measure 45 degrees. Well, we all know where 45 degrees is. It's obviously directly in between 0 and 90. So my polar coordinate 3 comma 45, I'm trying to go right in the middle here, right there. I'm going to put a degree symbol on. So that's how you plot polar coordinates. You have to make the circles for however many radii you have, depending what we're going to get up to, and then of course your angle. So let's take a look at this one. So again, I'm going to start with, and this one's not so bad, we have to go 2, but we need to address the negative. So this time, of course, only 2. You can draw still if you want to draw 3 circles, but we really only need 2. Got it? Now, a little different or a little more challenging to do the negatives. You have to, on this, because 60 degrees, of course, is going to be between 0 and 90 again. The first thing I'm going to plot, I'm going to do positive 2, 60. And I'm going to show you really quick and easy how you go to negative 2, 60. So 2, of course, on the outside, 60 degrees. I'm trying to ballpark between 0 and 90 where I think 60 degrees would be. That looks good to me. So that's positive 2, 60. Trying to put a degree on there. Okay, so to get it into negative 2, 60, and I'm just going to kind of connect this so you can see how far I went there, because I'm trying to kind of picture it in my mind. So I'm just going to go in the opposite direction. So basically I'm just going to extend this, but the opposite. So there's negative 2, 60. So you have to plot the positive one first, and pretend I drew that purple part perfectly straight, which is hard on this thing. And then of course, the purple one, I'm trying to circle that. This purple one's my answer. I get so mad at my Chromebook. I don't know why it's so difficult today. And of course, there's other directions we can go to get to that point. We could rotate negative, positive, coterminal angles. All of that's going to come into play here on our next one. All right, so let's plot negative 3, 120. Oh boy. So, and notice, of course, the radius. I'm keeping them all pretty small. I mean, who wants to draw 7 circles? I'd make my eyes hurt. I'm trying to draw 3 on here right now, and I'm about to lose it. Okay, so of course, because it's negative, we're first going to plot positive 3, 120. Maybe I'm going to pull this thing. I might just have to try to stand one-legged and draw these up here. Okay, so positive 3, 120. So of course, I'm a little past 90. So there is, pretend I do that straight, there's positive 3, 120. Now I'm going to go the opposite direction to make my negative 3. It is easy. I could draw this. It is. I'm getting very angry trying to write on this Chromebook. I hear everything. All right. Find 3 other points for part C. Now let's remember, I'm hoping this is, okay, that's my answer. So what they're asking you for is what are 3 other directions or ways you could possibly potentially get to that point? So remember, we could of course use negative angles. So if I could rotate negative 60 degrees, that would get me there. So I could do positive 3, negative 60. Would be one way to go. I don't know why that is like very irritating to me, but okay. All right. Now, we need 3 other points. So I'm thinking about how else could I get to that. Now, I could, of course, get to the green dot on the top left side and then throw the negative 3 on it. So I'm also thinking about, okay, well, to get to the green dot, I'm going to use another negative answer. I could go negative 90, 180. That'd be negative 240. So I could do positive. I'm trying to write a 3. I'm really going to have a stroke here on this thing. That's a positive 3 and a negative. I swear I'm going to lose it. Okay. But when I list the point over here, because I would have to flip it down, it's going to go to negative 3. Oh. I might just have to stand on one leg and make this happen because I'm really getting aggravated with this. Okay, now another way we could potentially get to, of course, the purple dot as our answer. So starting from 0, of course, if we measure around from 0, I could, of course, go 90, 180, 270, 300. So I'm trying to write a 3 and 300. That shouldn't have been so difficult to draw. So one thing to notice here, there's lots of different ways as we know to get to the same point. The coterminal angles, we know we can go around the circle different directions. So one thing just to point out, which I don't know how great it's going to let me do it on this, you can, that's it. I'm just going to stand on one leg because I'm really getting aggravated and my knee really hurts. Okay. I know. Oh, God, that hurts. So you could have 2 negative answers. And then of course you can have the two positive 3's. So for every polar coordinate, you can have 2 positive radii, 2 negative radii, just for the record when you list them. That looks like a child through. That's bad. Okay, all right, here we go. Plot the point. So just some in radians. Now, does it matter? Does it matter if you convert it into degrees? If you want to put 5 pi over 6 in degrees? No, it doesn't matter, but I'm going to keep it in radians. So radius of 3, 1, 2, 3, and of course 5 pi over 6. So thinking about, of course, if I label these in radians, just to help our cause here a little bit. So 5 pi over 6 is going to be 5/6, a little short of pi here. And of course out to the 3. So from there to there, there's my 3. Okay, easy enough. I'm going to gimp over and do B. It's going to be rough. It's going to be rough. All right, 2. All right, and negative pi over 6. We should know that one quick in degrees. What's negative pi over 6 in degrees? Negative 30. So I'm going to kind of ballpark negative 30. That looks good to me. So from there to there, got it. All right, and let's just do one more because I get over here. Okay, well, negative 1 pi over 4. Now, be careful with the negatives. Those just take a little extra tick, of course. 1, I like the 1. Okay, pi over 4, of course, I'm going to plot first 1 positive pi over 4, which is 45 degrees. This seems about perfect for today, everybody. Like, oh man, that hurt. And I think I just moved my smart board and now it's not oriented. Oh, God.
Stop.
I know. I know. Oh, okay.
Save this for later.
Ay. Okay. Oh, teaching at its finest today. Caleb. I thought about that, but I don't know if my short arms would reach high enough. I did actually think about that.
Just make Owen do it.
Yeah. Just make Owen do it. Okay. All right, let's read this. I'm going to hobble back over. I'm hobbling back. Oh, Lord. Okay. Woo. All right, keep moving on. Here we go. In rectangular coordinates, we just kind of talked about all of this stuff. Not true from polar coordinates. Obviously, like we saw in the one where we listed the 3 points, you can go positive angles, negative angles, different ways you can move around the circle. That is all that is telling you. So, multiple representation of points. Plot the following points, which we did 3, 5 pi over 6 earlier, and then it wants, of course, 2 more points, one with a positive radius, one with a negative. Okay, well, whatever. I'm going to try to draw it up here. So we drew this one earlier. I'm going to try to, it's a 3. I feel sorry for anybody who has to watch this video to learn this lesson.
Oh my God.
Sorry, whoever's gone today. My knee is broken, basically. I'm sitting at my desk trying to write on my Chromebook, which is problematic. All right, so 3, 5 pi over 6, we already graphed that, of course, earlier. 5 pi over 6 is 150 degrees, if that helps your cause. We're 30 short of the 180.
You know, I literally wasn't.
I'm trying to write. I'm really going to have a stroke. Okay, so we need some other points with it. It says we want one with a positive R, of course, and one with a negative R. Okay, all right. Well, of course, we could, it doesn't matter. We've got some choices here how you want to go around the circle. Obviously, we did 3, 5 pi over 6. I could go the negative direction. I could use a negative angle to get to there. So that's negative pi, another 6. So negative pi plus the 6, negative 1 is negative 7, 6. This is really... I'm about to throw my Chromebook on the floor. When our teacher finally flips out from her Chromebook. I'm getting angry, kids. I'm getting angry. Okay, so that's what I was trying to write. That should have, I don't know why, that swipe, I don't even know what that means. That's scaring me. Okay, so if it helps you, of course, think of this as 150 degrees, of course. This is the worst thing ever. So we could go, of course, negative 90, negative 180, and then I have to go 30 more. So negative 210. I'm just, because it gave it to you in radians, I'm just going to list I'm going to put it in radians. So negative 7 pi over 6. Okay, that was traumatic. Now, we did the one with the R positive greater than 0. I did cover that. Okay, so we need a negative one. Let's see how painful this is going to be. So, of course, to do a negative, we could just go try to get to the opposite side and then flip it back over. So that's what I'm thinking about doing. So, of course, if we rotate this down, oh gosh, because of course let's see, our 150, to get to this, we would have 30 more degrees there to get to your 180. I really didn't mean to move that. This really shouldn't be so challenging. So of course this would be 30 degrees. We could go down 30 degrees. That's supposed to be a pi. So we could do negative 30, negative 3, and then that would flip it back over, of course. That's one way you could get a negative. So if you plot, remember, negative 3, negative 30, that takes you to this one, and then you'd flip it back over to end up at that same point.
Could you put 11 pi over 6?
Yep, for sure. There's like 4 different options. I'll take 11 pi over 6 for sure. All right, let's try the next one and see how much this one makes me stroke out. Okay. Do you prefer, and I don't really care, radians or degrees? Degrees, of course, right? Okay, so 2 for my radius, got it. And we just know, we should just know, right, what's pi over 3? In degrees. 60. So I'm trying to estimate 60 degrees here. That looks pretty good. Okay, so we need some other points for that. Maybe. So of course we could do, let's pick green here. So we could go with a negative angle. We could rotate clockwise or down. We could go clear around. So we would have, of course, negative 90, 180, 270, 30 more. So we could do like negative 300 for that. That doesn't seem awful. I'm trying to write a negative 300. And okay, and of course you can put that in radians if I really get nitpicky and want it in radians. We need a negative answer though, so I'm thinking about the opposite side. I'm trying to draw a straight line to get to this. So if we want that point, we can flip it back over. I'm trying to draw a negative 2 there, which you can see is very problematic. Now, of course, to get to that point, we could come around this way to get to it. So we could do, this. I'm thinking in radians, that's where I'm hesitating. So we could have, it's really 4/3 pi for going back to the radians. I was in radians because that was pi over 3. So we added a 1/3 pi to it. This is a 4 pi over 3. I just went back to radians on that one, just to do it that way. But there are, of course, other answers, other choices to that, because remember, you can do 4 different ways, 4 different points to get to the same location on the graph grid. I'm sorry, this is such a hot mess today. All right, so how do we convert between the two forms? This is going to require a little Pythagorean theorem, a little SOHCAHTOA, and using your unit circle. So polar axis, of course, corresponds with the positive. I'm going to try to write on your x-axis. That looks like child's handwriting, which is nice. Okay, Now, to convert between the two, so if you wanna go from polar to rectangular, then we're gonna go the opposite way. So remember, our polar coordinates are our circles here. I don't know how many, it doesn't give you specific number. And remember, of course, your radius, and then you have your angle. That's a theta there. So I'm thinking about if you make a right triangle out of this. So I'm gonna kind of redraw this right triangle out here so it's not such a hot mess. So if we want to try to, of course, like convert this between polar into rectangular, all of this sort of stuff, of course I'm thinking about like SOHCAHTOA. So when we look at your unit circle, we use, of course, cosine a lot, because cosine is which coordinate? The first one. And we do sine. I'm trying to write sine on here, and look out. Because of course on your unit circle, sine is the second one. So when we look at our triangle here, of course cosine is the first coordinate, your x distance, sine of course how far up your y. So cosine adjacent hypotenuse, so x over r, sine opposite, it's supposed to be an equal, over hypotenuse. So there's our usual equations. Now we're just gonna manipulate those a little bit because remember your rectangular coordinates, x comma y. We know x comma y. So I'm like, well, I can make these x comma y, sure. I'm just gonna times by r to clear my fraction. Trying to write times by r. So when I think about really how to get them into rectangular coordinates, so I'm gonna have x equals, I like the x first, r cos of theta. And then I'm gonna have y equals r radius, of course, times the sine of theta. So that's how you can get your x, y off your polar coordinate. So this is why I said have your unit circle handy, because we're gonna need like cos of pi over 3 or sine of pi over 4. You probably know those, but we might have some other numbers we're gonna need off of that. So, next up, I am gonna do the rectangular to polar here in just a second. We are gonna do those. But let's go to this next example, and then I'm gonna back up the truck here, because we're gonna kind of look at both directions. So convert the polar coordinates to rectangular. Okay, I love this. So super easy. To do the x coordinate, got it, it's the radius, which is 4, times the cos of 60 degrees. I'm trying to write cosine. Now, maybe you know it, I don't know, look on your unit circle if you don't. What is the cosine of 60 degrees? So 60 degrees, there it is. Cosine's what? Cosine 60, 1/2, okay. So I'm gonna put a half in there. And you will get to use your unit circle on the test and everything. That's supposed to be a times 1/2 there, which is 2. 4 times a half. So there's going to be my x coordinate. Then to do the y, this should not be so difficult. I'm going to do, of course, the radius times the sine. Because y is your up and down. This is really causing me anxiety right now. Sine of 60, get that off your circle. What's sine of 60?
Square root of 3 over 2.
And of course, I'm just going to reduce the 4 and 2 down to 2 square roots of 3. So when I put my final answer, which I know I'm kind of at the bottom here, so I'm going to have my x coordinate, which we got 2, and then my y, we reduce that 4 over 2 to 2 root 3. So there are your x, y coordinates. And we're just going to carry on and do a couple more. So you're in radians, big deal, it's the same thing. So x, of course, is the radius times cosine for x. Trying to write cosine, 2 pi over 3. And we're just going to get that right off our circle. We're not going to stress about it. So pulling up the circle, 2 pi over 3. Got it, cosine I see there is negative 1/2. Let's put that in. Let me write it. So negative 2. And my knee hurts. Okay, let's do the y. So 4 times the sine. And I don't know if we need to do the last example, do we?
No.
Because this is taking way longer, me trying to write on this thing than it should take. Okay. Or sine, okay, what's your sine of 2 pi over 3? There's your circle if you need it. 3 over 2, of course. Okay, so my final answers for that, your x coordinate, of course, let's put -2 down. I'm trying to write -2, and then 2 over 3.
Oh my gosh.
All right, I am happy to do C. Do you need me to do C? No, I figured not, because of course pi is 180. Okay, so the next thing that comes up at us here is we have to go the opposite direction, rectangular to polar. So like I said, I'm going to back it up here. So back up to this, and let's look at how to convert and go the opposite direction on it. So let's kind of talk about that. So I'm just going to redraw this black triangle that I have down there with the x, the r, the theta on it. We're going to talk about that. So I'm just kind of redrawing this, trying to. Okay, so for this one, of course, so to come up with, because remember your polar coordinates are r comma theta, the radius and then the angle. So I'm thinking about, okay, to get r solved for on this triangle related to x and y, it's a right triangle, we can use Pythagorean theorem. So I'm like, all right, x squared plus y squared equals the radius squared. So there's the relationship between the radius and x and y, and of course I have to root it. So my polar coordinates to get the radius part is going to be the square root of x squared. I'm trying to write x squared plus y squared. Now we still have to talk about the theta part. And again, can't say as I actually memorize, oh, it's the square root of x squared plus y squared. I just do Pythagorean theorem, because how hard is that, right? I just old school it. And then we need the angle. So, and of course we're trying to use x and y. So I'm looking at my theta and how it relates, x and y. So I'm like, which trig ratio could I use to solve for theta with x and y in it? Well, I've got opposite adjacent. So which one has opposite adjacent? Tan. And of course to get an angle, we know it's the inverse. So to get the angle, you do tan inverse of x over x. That says y over x. I know it's a hot mess. Okay, all right. So let's go the opposite direction now. Try to convert rectangular to polar. So remember, these are your x, y. I'm trying to draw x, y. So one thing, an easy way to do this, because obviously there's so much to memorize, I don't get carried away with formulas, you know, and that's not how I roll. I just think about where is the point 2, -4. 1, 2, 3, 4. 2, -4. Got it. And then I just make my right triangle. So I'm not up here like, oh my gosh, how am I going to get that radius? What's the formula? I'm just going to use Pythagorean theorem. 2 squared plus -4 squared equals your radius squared. So 2 squared plus -4. I'm trying to write plus -4 squared equals the radius. All right, so we've got 4 plus 16. What's 4 plus 16? 20. So we're going to end up with the square root of 20. And the good mathematicians we are know to always simplify everything.
It did not say it on the test.
Square root of 20, what is it?
Simplify.
Okay, so my ordered pair, there's my radius. I'm trying to write a square root. Comma. All right, and then we need the angle, the theta. So again, I'm not going to be like, oh my gosh, how am I going to get theta? What formula do I use? Well, Los SOHCAHTOA. So we're going to do tan inverse of opposite adjacent. Punch that in. That's a -4 over 2.
Why did you put 2 times the square root of 10?
Oh, I don't know. I'm trying to write on this thing and it's stressing me out. How about 2 root 5? Sorry. Writing on this thing is causing me anxiety today, kids. I apologize. All right, punch in your calculator, but hang on. Are you giving your angle in degrees or radians? Does it say? So I don't care. It doesn't say, so I'll take degrees. So punch it in. Let's go degrees so we're all in the same style. So do second tan and -2. What do you got?
Well, I got -1.
Oh, Lord. Are you,
Wait, what motor is this? That's why.
are you in radians?
Maybe. Yeah, you are.
All right, so put it in degrees, retype it in. What do you have?
She literally said we could have it.
I
You
said,
just said we could have it in whatever.
I did, but I said let's go degrees so we're all the same.
-63.4349.
Okay. I'm just gonna round, right? Okay, so one little nuance here, of course, okay? So the negative, don't let the negative freak you out. Remember, the negative just affects your direction. You're rotating clockwise, you're rotating down. So I'm just thinking about, okay, we rotated down 63.4 degrees. The negative is just the direction. They, of course, one of these like unwritten rules when you give your angle though, when you do your polar coordinates, they don't want you to give a negative angle. They always want a positive angle. So I'm just like, well, okay, I can measure from 0 around. I would have to, you're 63.4 short of a full circle. So how are you gonna figure out that distance if you're 63.4 short of the full circle? Yeah, I hear it, 360 minus it. Because they want positive angles. So punch that in, what do you got?
296.
Got it.
I mean 6. Thank you.
I'm trying to write a 6. Got it. Okay, so again, I don't necessarily freak out about formulas, I just a little common sense. If I plot the point -5, 5√3, we're gonna be in quadrant 2. Now I'm not gonna get crazy, especially the 5√3. I'm just gonna know I'm going left 5 and up 5√3. It's gonna be about up here somewhere. I'm trying to put a point. So we went left 5 and we went up 5 square roots of 3. So the first thing we need is the radius. I'm trying to write an R there. So I'm just going to use, of course, our old school Pythagorean theorem. Simple enough. So -5 squared, 5 square roots of 3 squared is going to be 25 times 3. So we end up with 10. Square root of, I'm trying to write a 10 there. Okay, so next we need the angle. So again, I'm just using SOHCAHTOA here, opposite adjacent. Well, you could use any trig ratio. I'm going to go stick with our opposite adjacent. So tan inverse, opposite over adjacent. Okay, punch that in. What do you got? Okay. And I don't care about the negative so much, that just is telling you directions. I care about the 60. Now, I'm not going to list 60 degrees though. It is such a hot mess, people. I'm not going to list 60 degrees as the answer because 60 degrees is in quadrant 1. It's between 0 and 90. We have to measure from 0 over. So you really want how many degrees? 120, yes, perfect. I'm trying to circle the, maybe, okay. So we really want 120 degrees because remember you're measuring from 0 over into quadrant 2. 60 degrees is in quadrant 1. Okay, we're on the home stretch maybe, I hope. To convert rectangular to polar, this is easy, I promise. Remember, x is r times the cosine, that's a times. A theta, and remember y was r times the sine, because sine is your up and down. I'm trying to draw theta, so I'm going to use those here to do these equations. Okay, so it says express the following in polar. So we want to get rid of x and y, and we want to end up with like an r or a theta in there. So I'm going to just replace the x with r cos theta, but it's squared. I'm trying to write squared. And then 4, and then y was our r sine theta. I don't know why it keeps moving the problem, which I find very irritating. Okay, square it out. Let's see what we can make happen here. So we're going to have r squared, of course, cos squared, and then the right side's just the right side. first we wanna know what r equals, that's what we're all about here, because our ordered pairs are r comma theta. So I'm like, alright, well, let's try to solve this for r. So I'm thinking about I wanna get r by itself, that is my goal. Well, if I divide this side by r, and of course I'm gonna do this one. So r squared over r, of course, will simplify down for me to just a single r, because I'll have my radius, but I still need to get the cos squared off also. I'm trying to write cosine squared. Okay, so r squared over r is r, and these cancel. And I'm gonna write this a little prettier, of course, because we're gonna use our trig functions. What's sine over cos? Tan, so we have a tan in there, and you also have an additional cos in the bottom. So you have tangent and you have secant. So I'm just gonna put it 4 tan secant. Got it. I'm trying to write tangent and secant. There is my equation for r in polar coordinates. You don't have to do anything else. All right, let's do this guy. So y, I'm gonna put the r sine of theta. And x is the r cos theta. But of course we're squared. And like the last time, I'm gonna square out the right side. So r squared cos squared, maybe. Now we want to solve for r, so we have to be smart about where we're dividing. I'm gonna divide the single r off of this side, because r squared over r on the right will simplify to just an r. Now, so I've got the r on the right side, so that means I also want to cancel out the cos squared. I'm trying to solve for r. And I gotta do it on this side. Really, I'm gonna throw my Chromebook pretty soon, kids. Okay, so r squared over r, got it. Cancel. Okay, you got sine over cos, and you have an over cos again. So we end up with kind of close, just not the 4, right? And they are similar. I'm trying to write secant. Okay, are we ready finally for the last one? Let's see if I can write on this thing. Okay, this you gotta be a little more creative. There's no hard and fast rules of things to just plug in. So express the polar equation in rectangular coordinates. If possible, determine the graph of it. We don't have to actually draw the graph, we just have to think about it. So right away, I know my coordinates are polar coordinates, everything. There's no secant in them. So I'm thinking, you know, that's always related to sine and cosine. So I'm thinking about secant's 1 over cos. Maybe over cos. So I'm going to think of that really as 5 over cos, really. Trying to write it over cos. Okay, now as always, we like to clear fractions out. Nobody likes a fraction, so I'm just going to times by cos. It should say theta, but I'm at my limits on writing on here. So I'm going to have r cos of theta over here. And 5. Now, what's hopefully jumping out at you, what is r cos of theta? X. Got it. We are in rectangular coordinates. We have x or x and y in it. Got it. Now, it also just asks you to determine the graph. We don't actually have to draw the graph. That's a super easy graph, though. That's just what type of line? Straight up and down. That's just our vertical line. So I'm just, because it wants you to determine the graph, so I'm trying to just say we got a vertical line. Maybe. I'm going to say that. Okay. All right. That was fun. So I'm looking at this guy. I like the 2 sine theta, because right away I'm thinking, well, sine, I'm thinking y, right? We've got the y on it, but our y is r sine theta. I need an r over there with the sine of theta. So I'm going to get creative. I'm going to multiply each side by r. No hard and fast rules here. You just got to kind of, so r squared, and I like the r by the sine. That's just how I roll. Sine. Okay, now, r squared, remember we found r squared on our right triangle with Pythagorean theorem. R squared, of course, if we go back and look at our converting here, R squared, just R squared, not with the square root of R squared is x squared plus y squared. So I'm like, oh, okay, well, I like that. I'm trying to write an x squared plus y squared and not totally yell at my Chromebook. Squared! I'm trying. Okay. And on the right side, your r sine theta, there's your y. I'm trying to write 2y, if that's possible. Okay, so of course I'm thinking about what the graph is. I mean, we don't have to get too more carried away. We've got our x and our y in there. Do you remember from geometry, when you have x squared plus y squared equals like 9? I'll give you something easy. What sort of shape is that? That's a circle.
Oh, yeah.
When you have the x squared plus y squared, that's our conic section of a circle. We will eventually have an ellipse and all sorts of other good stuff. All right, I am